Okay, in this video I'd like to talk about a new topic, and that new topic is called dispersion. And what dispersion will allow us to do is answer some remaining questions we have on our sheet about colors that we see in the sky and some things that happen with the atmosphere and the sun and the moon and things like that. And I'll just start this conversation by talking about this object here, which you probably know is a prism. So what a prism is here is sort of, as you can see here, it's sort of this triangular shaped piece of glass, and it has sort of a thick body like that, but it's all in a triangle. Like there's the top of the triangle going on the other side there. And the way prisms are normally used is you might set it up like this and send some white light in this way, and what you'll see on the other side coming out of the prism is you'll see all the colors of the rainbow coming out. So blue will always go like that, red will go like that, there'll be some greens in there, there'll be some oranges in there, that sort of thing, and maybe some yellows as well. So what you get going in is you get your white light going in, but you know that white light is really a mixture of all the colors of the rainbow over here, and so you sort of get the light, let's just say, use the word separated, coming out. And this is one of the first proofs that white light was made out of all the distinct colors that we normally see. This is a famous picture here of Isaac Newton. Of course, the famous scientist from the 1700s, and he was one of the first to demonstrate this here. So this would be Newton right here, and what he's holding up, he has this sort of laboratory all closed off here, and I think we discussed this in a previous video about what he's got up here. He has this prism up here that he's holding, maybe a little triangle like that up to the hole in the door. The white light comes through, streams through like this, enters the prism. I'm not sure what this is streaming, but the way the artwork shows you, then here are the colors separated once again, where you see like the reds here and the blues down there and some greens and oranges and things in between. So he was one of the first to do this and demonstrate that light is indeed made up of those constituent colors. He made it onto an album cover, Pink Floyd, The Dark Side of the Moon. We showed this on the very, very first couple slides of the class here. We discussed the dark side of the moon, but now, of course, we have the prism effect in here. And one thing that you'll always notice about the prism is that the reds are always on the top and the blues are always on the bottom, and say the greens are sort of in between. You see that here. You see it sort of in Newton's work here, where the reds are here and the blues are down here, and I tried to draw it that way when I gave you my introduction up here. I had the reds on the top here and the blues down here. Okay, so we sort of see a little trend in there. Here's an actual prism being used, and again, I just took these off of Wikipedia. Here's a white light source coming in. Here's that triangular prism shape here that looks like this. There's that triangular prism shape like that. So the white light goes in, and you see all the constituent colors coming out once again with the same trend. That red's on the top there and blue's on the bottom. There's another image from Wikipedia which shows the waves of light coming through the prism, red on the top and blues and violets on the bottoms there. So the issue then that I'll pick up now on dispersion is as follows here. Here's what dispersion is about. It's a bit of a question that you'll have to think about here. Go a little thinner here. Dispersion. Here's sort of the issue here to think about. Okay, so here's that piece of glass again, maybe that side of the prism going in. And what we'll have here is we'll have some light going in, and it'll hit this point here. Now, the question before us then is, okay, we know about this. What's going to happen at this surface here? Say if this is air here with an index refraction of 1.01 or something like that, and this is glass in here with an index refraction of like 1.5, we know that what's going to happen at the surface here, as we discussed, we'll get some refraction. And we discussed that, right? You can just do your full technique in here. You can go right to that interaction point right there. You can draw the normal in there like that, and it looks like we have light going from a thin substance like air to a thicker substance like glass, so it's going to bend towards the normal. We know that, so we can just continue on with what we know about refraction and draw the light refracting like that. So you see the two angles there. It's related by Snell's law. And we covered all this in a previous video. But the question then about this is, wait a minute. If white light goes in like this, and we draw white light going out, we know that white light has all of those colors in it here. We know that white light there's red in there. We know there's blue in there. And we know that there's green in there. And the oranges and all those colors are in there. why aren't they coming out over here? Like, what law is going to tell us to draw the outcoming light the way it looks on the prism here? What law is going to tell us to separate the reds and the blues like that, right? Like, where is the separation? Like, where is that in here? And if you remember, Snell's law just said that n1 times theta 1 is n2 times theta 2. And I know we're not basing this class on equations much, but all this tells you is then if you have some indices of refraction here, like air and glass, you just have a couple angles. There's actually nothing having to do with color in this equation anywhere. So I asked again, when I go down even to here, how are we going to handle the color separation? Like, where is that in this analysis? What tells us to draw in this figure here the red up here like this and the blue down here like that, and maybe the green somewhere in between, or something like that? What would tell us to do that? Because we just don't see that in here. And the simple law of refraction just says, hey, light goes in and it comes out. What's going to handle the color separation? Well, what handles the color separation is the action of dispersion. And I'll tell you what that is in the next video.